So we have developed a dynamic control model for BOF steel making process using METSIM. So basically the idea is that it is based upon a flow sheet modeling approach where there are certain number of reactors which are defined in as an equilibrium reactor, and it is connected through the flow of streams to the bulk reactors consisting of liquid metal and liquid slag. So basically all these reactors are being defined appropriately in accordance to the various stream properties which are coming in and which are going out. So accordingly we have defined three free energy minimization reactors, starting from this metal gas reaction that defines the hot spot zone, metal gas slag reactor which defines the immersion zone, and metal gas reactor which defines the entire bath. So this has been defined to include the effect of organ purging in the last 30% of the process. Now all these activities, particularly the charging sequence, charging of the various raw materials as well as their dissolution rates, are included in schedule actually. So there are a lot of variable definitions and lot of definitions of activities participating in the chemical reactions, particularly for slag and metal. For example, the activities for all these components are being defined here. This is called IACT routine, yes, activity coefficient equations. So basically these are all components which are participating in this process. And for example, here just I want to show you that for liquid carbon we have assumed activity is equal to 1, sorry, uh, for slag component, let me just show you the slag component. This for example, one second, this for FeO. So this is the equation which defines the activity of FeO in the slag as a function of composition and temperature. So similarly, for all the components present in the liquid metal phase and liquid slag have been defined like this way. So there are a lot of definitions in this model. Now uh, I I should just demonstrate you that how this model works actually, because the detailed description will take a lot of time. So the interested people may read my publication in this regard, where I have given the detailed information in this regard. So now I am going to start this simulation. So what it is going to do is that it is going to plot all the informations of the process, basically like what is the composition, evolution of the composition of the liquid metal, liquid slag, okay, gas phase, okay, the hot spot temperature, the temperature of the liquid slag, the liquid metal. So all the informations are being evaluated at interval of every second, and then it will result in the entire dynamic simulation of the process. Uh, in this model, we can do a lot of changes in the operating parameters here and there, and a lot of changes in the kinetic parameters, like how much fraction of the bulk metal or the bulk slag is going into each of the free energy minimizer reactor at every second. So basically somewhere we are getting this information from the mass transport control equations. So there is a way of doing it. So for that also I suggest you to read my publications, where I have performed these dynamic simulations of oxygen steel making process using flow sheet modeling based approach. So basically this is a very interesting and innovative approach of modeling such an interesting and complex steel making process, and it has been represented in a very beautiful manner in a flow sheet model, and behavior of the process can be simulated in a very sophisticated, and you can say that in an efficient manner. For example, here this reactor, which is a gas metal reactor. So here we are injecting, we are looking the effect of organ purging. um, um, effect of organ purging on metal composition, particularly the dissolved carbon and dissolved oxygen and other elements composition. So one of the exercise that could be done here is that if you want to see the effect of carbon dioxide purging here instead of organ, and what is the effect on other process dynamics that can happen because of that, so that can also be tested from a lot of things which we can test in this model, but this is just for the purpose of demonstration only. I request interested industries and other partners to contact me, and if there is any kind of collaborative project possibility to work in this direction, please contact me. Thank you very much. Now this simulation is running, so I will just keep on going this process till this simulation is getting completed, until this entire plot for this 900 second blowing period is being completed. So since it performs a lot of calculations, so because of that, subject to the processing ability of the computer on which I am working, it is taking a little bit longer time. But if the computing speed of the machine is good, these simulations can happen in even in a shorter time also as well. Thank you very much.